ship was a billy of tea. The winds blew hard about it down. Blow me bully boys, blow. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tongue is done, we'll take our leave.
Good idea. Where's my drink?
2 weeks from shore, went down on her.
I haven't seen far too long to come in without some drink. But first, apparently, I've got to collapse something, and then I will find the devil that took my sword, and I will club him until he gives it back. Turn off this blasted music. I've been hearing these ballads for months on the open seas, and I can take no more. Good day to you. Today we're going to be talking about statistics. Statistics. Someone said once about statistics, there are lies, damned lies, and then there are statistics. That was Mark Twain. At least he's halfway credited for the quote. Another guy named Benjamin something said it as well. And we're going to take a look at the very first statistic. This one over here. Global average temperature versus the number of pirates. Did you know? We've heard all things about raising temperatures with the fires that have been around us recently. But did you know that the reason for temperatures on the increase has nothing and absolutely all to do with carbon dioxide emissions and other such nonsense, and greenhouse gases and burning of petroleum and coal and whatnot? What it has to do with the lack of pirates in the world. Look at this. In the year 1620, 1820 even, there were 35,000 pirates. 35,000, mind you. There were 45,000 in 1860. 1880 it was down to 20,000, and then in the 20th century with industrialization, up goes the temperature, and up it goes, and up it goes. In 1940 there were fewer than 5,000 pirates. In 1980 there were only 400. And then in the year 2000, there were only 17 pirates in the noble trade left on planet Earth. You can't really terrorize the seas with only 17 people. So, if we hire some more pirates, well then, global temperatures should decrease. It's the only solution to the problem. So therefore, I got tired of teaching, and I wanted to do my duty to keeping the earth a sound and healthy place, so I decided to be a pirate. Somebody stole my sword though, and I'm still angry about it. Anyway, so today we are going to talk about statistics. This is number 4 or number 5 on the actual topic list. And it goes along with math. I generally have this section in my human science section, but I decided to put it here since we're talking about math and there's a lot of different things. What? There it goes. Nope. Anyway. I don't really know what's going on. Sorry. There we go. Whoops. Whoops. Here. I really don't know what's going on, actually. So. Oh, I see the problem. There we go. Sorry about that, guys. Sorry, technical difficulties. I may have to cut a little in here. But here we go. So, that should work perfectly. Or maybe I won't cut anything. I'm a pirate. I'll do what I wish. That's right. I'll do what I wish. I don't need to cut anything to make it more convenient. So, nevertheless, what we're going to do is we're going to talk about statistics. And as a matter of fact, I'm a teacher today with a baseball bat. I look almost as good as that chick in with the ponytails in that silly superhero movie, anti-superhero movie. Anyway, lying with statistics. I'm going to teach you how to lie with statistics today. The question this year asks, conceal as much as they reveal, something like that. I'll put the actual topic in. We'll talk about the topic itself. So what we're going to look at is how I can lie with statistics. It's really quite interesting. What you saw here when I showed you just a minute ago with the average temperature and the pirates, what you saw there was a false correlation. I'm going to talk about false correlations a little bit later. But anyway, there are three kinds of lies. Lies, damned lies, and statistics. Mark Twain quoting Benjamin Disraeli. I don't know who said it. I can't get any straight answer, so that's what I saw. I just put it up there. I wasn't alive. I didn't know Mark Twain or Ben. So, do my best. Statistics is an invaluable tool for human science and for natural science. We prove things statistically. We can't get any knowledge creation in human or natural sciences without using statistics. We want to be objective. We want to do experiments, and we want to give the results of the experiments, and that can't be done without statistics. So it's important. They reveal information about the behavior and attitudes of large groups of data, experiments. Remember, this is geared towards human science, so it's a little bit focused on that, but the statistics question works pretty well anyway. They help make clear relationships between factors. Whoops, there's a pirate in the way. Anyway, they're useful for empirical support for interpretations. You can't prove anything scientifically without data to do it. Otherwise, you have philosophy. You have ideas and theories with no proof. This creates proof. This is important, and it's a mathematical tool, and this is where I'm getting at with this lesson of tying it into math. It's about math. It's about using math to describe relationships in the environment around us. And so, however, there are many pitfalls in statistics and much opportunity to mislead a population. You mislead a population. You can mislead people with statistics. And I'm jokingly teaching you how to lie with statistics here. But my golden locks, sir. That's why I cut my hair off. Anyway, so Larry Liars, easy steps to learning how to lie with statistics. Larry Liar. Who doesn't like alliteration? Anyway, so look at these two. Fear of war is at record levels. Sickness, robbery, murder, war. And look at this. Poverty's on the rise again. Look at that. All kinds of stuff in there. We'll talk about those later. There's methods of duping. You just generally lie to people. Intentional deceit. You want to represent a truth which you've made up. Something that isn't true. Now, you see statistics all the time, and you're going to see a lot of statistics in this election year. And you're going to see two statistics saying opposite things, and both say they've done a study or a survey. What? I mean, it's really beyond nonsensical. So keep your eyes open. Selective data use. Do not report on all the data. There's no governing body of statistics for, you can produce all kinds of statistics. I mean, if you're going to be very, very serious and do it very right, sure, there's guidelines. But any magazine can produce statistics if it wants to. And this is the thing. Which data do you report on? Let's say if you find a whole bunch of data that doesn't support your thesis. You don't have to report on it. Who would know? Who would know? All right. Faulty assumptions. Do not leave the thinking for the audience. No thinking for the audience. You do the thinking for them. You make the conclusions. You don't put data just out there and let them look at it. What you do is you put it out there and you tell them what it says. And then creative graphics. Oh, people love to look at things. They don't want to read. They want to look at a simple thing. Okay, and incompetence. Well, you can just make mistakes too, but we're not going to worry that much about it because nobody needs help being incompetent. You just are incompetent. Anyway, so learn to sample correctly. All right, let's talk about sampling. Sampling. Carefully choose the size of your sample. I'm going to put these up here first. So, random sampling. Okay. Now, which sample should you use? What if I want to, for instance, say that Donald Trump, what if I want to show support that Donald Trump is going to win again? Or if what I want to show support that people really, really like the policies of any given mayor or something like that. Who should I ask? Where do I do my asking? Now, people like to think that sampling is done randomly. Well, it very often isn't. What is random? Let's say I want to ask about Donald Trump and what they thought of his presidency. So I go down to Texas, and I go out to the golf course where people are fairly wealthy, and I ask them, so what do you think of Donald Trump? And I very likely could, just random people coming by, I very likely could get lots of examples, lots of answers and statistics to show that there's a support for Donald Trump. However, if I went down here, I've been back in time a couple weeks, and I went to the Chop Zone here in Seattle, and I went and asked people, yo, what do you think of Donald Trump? Let's do a survey. Oh, what kind of answers am I going to get? So which sample am I going to use? I can go around and pick whatever sample that I want. Nobody's making me do statistical surveying in any way, shape, or form. I can do it however I feel like doing it. So I decide I want to show that, any given thing I don't like, people don't like either. So I go somewhere where I know they've been negatively affected by it. And it's really that simple. And I am doing sort of proper statistics, but I know which sample I'm looking for. Carefully choose the sample size. How many people does it have to be? Now, if you want a really good sample, you need about 1,000 data points, all right? Okay. If you want a really good one, and I'm going to talk about random sampling in a second, but I don't need 1,000 data points in Chop Zone in Seattle, or the Portland riots or protests, whatever you want to call those. I don't need 1,000 data points and a thing like that to do good sampling, because I'm going to get pretty much a similar answer for 1,000 people. But if I want to show a point, then that's where I want to do it. Carefully choose your sample size. How many do I need? 10? 50? 30? Do I have to tell people how many people I've used in the sample? Well, a good study will do it. But no, look at the stuff. You'll see, if you look through information on the internet, in magazines, whatever, if they even produce those things anymore. I'm joking. But on the internet and stuff, look and see how many people. Some of them will say it, but a lot of them won't even say how many people have been asked. Okay, and then random sampling. Here's random sampling. People think random sampling means, when they say random sampling has been done, people think random sampling means they have a massive sort of demographic spread, that they ask poor people, they ask rich people, they ask people of all races, they ask people of all economic backgrounds, they ask people of different religions, they ask 80-year-olds, 70-year-olds, 60-year-olds, 50-year-olds, 20-year-olds, whatever. They ask a massive wide range of people. And then you get a really good random sample and a really good sort of set of statistics which show a clear picture of what people think. Now, this is not how it is done very often. A good sample does this, but this is both very time-consuming and very expensive. You have to have people going out and doing these things and canvassing areas. And you can't only call people. You can't only do it on the internet, because those people have internet and they have cell phones. To really, really do a good job, you really need to go person to person and you need to ask people. Okay, so by nature of computer sampling, you're talking about people, everybody who has computers and their internet, they're technologically savvy enough to use a computer, and so on and so forth. So you see what I mean? There's a real problem here. But say it's random sampling. All you have to do is say it's random sampling, because the word random is ambiguous. What does random mean? Random can mean that you just didn't pick the person specifically. You didn't say, I'm going to call you up because you are a demographic I like and I'm going to ask you questions. No, random is used in sampling as a way to say basically, that they just walked by. So, let me go to Chop Zone, or let me go to the rich golf club in a Republican area, and let me random sample people who walk by. That's random. It is. But it's not, if you're going to deceive people, which I'm trying to teach you to do, really, tongue-in-cheek, I'm not. I'm trying to teach you to understand how sampling can fool people. But anyway, so you say that it's random sampling. Okay? The three best ways to lie with sampling are not only should you ignore any possible biases in your sampling method, but you should actively, I don't know why I did that, but it's funny, maybe. But you should actively seek to find samples which will give you the answers you want. That's what you do. Pick your sampling properly. Still angry about my sword. What kind of pirate am I that has a baseball bat? Should have a sword, a scabbard. That's what I want. I want a scabbard. And I want a small one too. A dolk. Anyway, claim everything has been done randomly. It is expected of you. And do not elaborate. For emphasis. Do not elaborate. All right. Just put it out there. You don't need to tell people everything. All you need is the statistic. All you need is the graph. Just, okay. So, I'll do this a little bit, and then I think I will stop this and do a second version of this. So anyway, trickery with averages. This is a famous saying by a guy named Antonius Sturtius, very clever man. It says, ambiguity is a statistician's best friend. Antonius Sturtius. That's right. And ambiguity is a statistician's best friend. Look at this. Pick the average that suits you best. There are three measures of central tendency. Mode, median, and mean. Like me. Mean. That's right. People on the seas fear me. Mean. The sum of all values. You guys know what it is. Paid attention to math. Those things fell down. They're supposed to be my boots, but mean. You guys know what the median is. The middle value, and then mode, the most common value. All three of them are called average. So which one do you want? You can just say the average answer, the average whatever. People generally think it's the mean, but it doesn't have to be the mean. So look at this. Here. Whoops. There. Now, this graph says here an average number of robberies in per county. And it says over here, this is Treeville, I guess. In Pine County, 264 robberies. Maple County, 82 robberies. Birch County, 75 robberies. Fur County, 56. Alder, 51. Teak, 53 or 43. Oak, 26. Beech, 16. Walnut, 16. Chestnut, 16. Sandalwood, 16. Driftwood County, 8. And Neverwood County, only 1. But look at this. Mean. The mean is 51. So if I were to be running for mayor of this town or state, well, senator, whatever, governor, if I were to be running for a political office in this state, and I were saying, look at the job the previous incumbent has done. The incumbent has done. It's a terrible job. The mean is an average of 51. 51 robberies. This was way up over last time. But if I was the incumbent, I could say, no, there's only an average of 16 robberies. And I could both say that's the average. The ambiguity is what's good for a statistician. So, with that, we'll take a break. I need to get to the inn. I've got to get to the inn. Just got off the ship. I need a bath. I'll have the steward run me a bath. But I need some music to leave with. We certainly do. How about this one?